Hi there, in this video we are going to learn the basics of animation. Animation is the process by which you set and control the behavior of a property or parameter over time. When animating a character, for instance, you are constantly changing the bone's positions and rotations and setting poses for the character over time. In Houdini, animation is really fun, and you can animate every parameter or attribute. The most common ways to do animation are manually setting keyframes, using expressions to drive the animation, or using motion effects to drive the animation. Setting keyframes for the key positions is the traditional animation method. You set the key positions and then the software generates the in-between frames. Using expressions to animate a parameter or attribute easy the animation process, as you don't need to set keys. Simple expressions will save you a lot of time in the process. Motion effects gives you powerful tools to precisely set and control your animation. It also gives you presets to quickly add animation to any parameter or attribute. Okay, let's start with the lesson. In the play bar, we have the timeline and the playback controls. Let's click on the play button. Now, the playhead moves extremely fast. To have a proper speed, it's necessary to enable the real-time toggle option. Click on the real-time toggle and play again. Now the playhead moves correctly. In the playback controls, we also have the stop button to stop the animation, the last frame button to go to the end of the animation, the play backward button to play the animation backward, and the first frame button to go to the first frame of the animation. In the options buttons, we already see the real-time toggle. Besides, there is a button to control how to loop the animation, another button for the audio panel, and finally the global animation options. Here you can set the frame rate at which your animation will be played. This value is set in frames per second. For film, this value is 24, and for television it can be 25, 50, 30 or 60 depending on the format. Besides the frame rate, here you can also set the animation length by setting the first frame and the last frame of the animation. Let's leave the default values. So, as the animation length is 240 frames and the frame per second rate is 24, then the animation duration will be 10 seconds. Close the window. Let's create some geometry to have something to work with. In the Shelf dock, in the Create tab, Control-click on the Platonic Solids tool. A tetrahedron is created. In the Operation Controls bar, change the solid type to soccer ball. Now we have a ball to play with. To manually create a keyframe, the process is simple. Locate the playhead at the frame you want to create the key, and then hold Alt and left-click on the parameter. For instance, at this moment, the playhead is parked at frame 1. Now, to animate the translation, hold Alt and left-click on the translate name. As translation is a vector, a keyframe has been created for each of its components, TX, TY, and TZ. The three fields turn green to show that a key has been set for these parameters. And in the timeline, the key is also represented in green at frame 1. Use Ctrl-Z to undo the keyframe creation. Let's just create a key for the vertical translation. To do this, place the mouse pointer over the TY parameter. Hold Alt and left-click. A keyframe has been created just for the vertical translation. And in the timeline, you can check that the key is located at frame 1. Okay, we have our first key for the vertical position at frame 1. Now, move the playhead to frame 24 and move the ball to a new position using the vertical handle, or just type a value and tap Enter. The field color has changed to indicate that there are pending changes. To commit the change and create a key, hold Alt and then left-click on the parameter. Now the key is created, the field is green, and we can check the key at frame 24. Let's reframe the view to see the ball. To check, scrap the playhead between frames 1 and 24, and the ball moves. It's working. Now, let's add another key. Move the playhead to frame 48. Return the ball to its initial position using the vertical handle, or just type in 0 in the vertical field. Again, to create the key, hold Alt and left-click on the parameter. The key is created, and we can check it in the timeline. Play the animation, and it's working from frame 1 to 48. To zoom in the timeline to this range, type 48 in the end frame field. Now, the 48 frames fill the entire timeline. Let's play again. It's working. We created 3 keys and then Houdini interpolates the movement in between the keys. But how this interpolation is done, and how can we edit the animation? To edit the animation, we have the animation editor. Click on the animation editor tab to see its content. This tab displays animation data, also known as channels. For a selected node, the animation editor displays the channel list, and each channel represents graphically the animation data for the corresponding parameter. We can see one curve because we only animated the translate Y parameter. We can see the 3 created keyframes as small diamonds connected by curves. Let's cover the basics features of this editor. To start, to navigate in the graphic, use the same options to navigate in the network editor. Middle mouse button and drag to pan around. Right mouse button and drag horizontally or vertically to zoom in and out in the corresponding direction. Besides, at the top right side you have 3 useful functions. Vertical adapt to fit the curve vertically, horizontal adapt to fit the curve horizontally, and frame selected to frame the selected keyframes. Besides the current graph format, we can also see the animation data in a dot sheet format. This is a more compact representation, but here you can quickly edit individual keyframes or blocks of keyframes without worrying about the curves. But for precise control, the graph mode is a better choice. In the graph view, the horizontal axis represents time in frames, and the vertical axis represents the value for the selected parameter. If we select the first key, we can see at frame 1 the value for translate Y is 0. Then for the second key at frame 24 the value is 3, and for the last key at frame 48 the value is 0. You can drag the keys in the graph to modify its frame or its value. The shape of the curve between 2 keys controls the variation of the value between the keys. To modify the curves, move the keyframes or just drag the handles. With this curve, you would expect low speed at the beginning and high speed at the top position. Let's check on the scene view. And it works as expected, although the movement is not natural. Let's return to the animation editor and drag the handles to shape the curve as a parabol. Let's check again in the scene view. The movement is better. Perhaps a minor adjustment. That's better. Reframe the window using the spacebar and the mouse buttons. Now, let's animate the translation in the X direction, not using keyframes, but an expression. How do we enter an expression to animate a parameter? Well, quite easy, just type the expression in the parameter field. But what can we type? The most used variable is the time in frames, and its representation is as the $sign and the F character. Let's type $F in the Translate X field and enter to finish. At the moment, we see the expression but not the value. To toggle to the value, left-click on the parameter name Translate. Now we see TX has a value 1 assigned, and 1 is our current frame. If we advance frame by frame, we can see how the TX value matches the current frame, and the ball is moving in the X direction. If we play the animation, the ball moves at high speed in the X direction. To reduce the speed, let's modify the expression. Let's divide $F by 10 to make the speed 10 times slower. Play the animation. Perhaps too fast. Let's divide it by 15. Play the animation. Now perhaps too slow. Let's divide it by 12. Better. Reframe the window using the spacebar and the mouse buttons. And extend the visible animation length to the original value, 240. Play the animation. Well, we just have one cycle. To extend the animation, we could start creating more keys, but this way is boring and takes time. And in the animation editor, there are functions to extend or extrapolate our current animation. Let's go back to the animation editor. By the way, besides our green curve that represents the white translation, now we have a red stair-step graphic that represents the X translation. As the X channel is driven by an expression, we have no handles and we cannot edit the graphic. Okay, back to our task. How to cycle our animation. First, click the right mouse button and drag horizontally to zoom out the view. Also, use the middle mouse button to pan the view. Now, go to the Translate X channel and right-click, go to Channels, then to Extrapolation, and finally select Cycle. Done. Our animation has been extrapolated. Let's check in the scene view. Play the animation, and it works fine. Go back to the first frame. Now, if I would like to animate the rotation for the ball around the X-axis or the Z-axis, we simply write an expression on each field. Type $F divided by 2 in the Rotate X and the Z fields. Play the animation. Now the ball spins around the X and Z axis. Okay, let's try a final task. First, delete the animation in all the channels but the Translate Y, and also set their values to 0. To delete an animation channel, right-click on the parameter and select Delete Channel. Let's do this for the channels Rotate X, Rotate Z, and Translate X. Play the animation. Now we have our bouncing ball at the center of the scene. reframe the window using the spacebar and the mouse buttons. I would like the ball, while still bouncing, to rotate around the center of the scene. Let's move the ball 5 units in the X direction. Now, if we rotate around the Y-axis, the ball rotates but around its axis. To rotate around the center of the scene, we have to move back the pivot translate X 5 units. Okay, the pivot is now at the center of the scene, and if we rotate the ball, it now rotates around the center. So, let's animate it by typing $F in the Rotate X field. It works. But as we don't have enough frames in the timeline, we could not complete the full circle. Let's add more frames, but how many? To find out, let's go to the animation editor. Here you can check that our original animation is 48 frames long. To loop animation, you use the original frame length -1, 47 for this example. If we need 9 additional cycles, then we need 9 times 47, which equals 423 frames. Then 48 frames from the original cycle plus 423 frames from the 9 additional cycles gives us a total of 471 frames. If I type 471 in the end frame, nothing changes. I have to change it in the Global Animation Options window. Open the Global Animation Options and change the end to 471. Apply and close the window. Zoom out and pan the view to fit the 471 frames. You can see the end of the cycle corresponds exactly with the end of the animation. The translate Y or bouncing movement is correctly cycled. Let's go back to the scene view. What about the rotation Y movement? The unit for rotation is in degrees, and we know a full circle has 360 degrees. Our animation length is 471. If we leave the expression for the Y rotation to $F, it means that for the end of the animation, the ball will rotate 471 degrees, right? But we need not 471 degrees, but 360 degrees. Basic math can help us here, and specifically the rule of 3. We just need to divide $F by 471 and then multiply by 360, and we are done with the maths. Play the animation. And it works as expected. Fine. We have covered the basics of keyframing and expressions. To end this video, let's also cover the basics of motion effects driven animations. Let's delete the animation channels and set the X position and pivot to 0. Open the hidden tree view on the left. We can see our platonic object 1, and inside this container we have the platonic 1 geometry. To animate the Y translation using motion effects presets, right-click on the parameter and then go to Motion Effects. In the bottom part, we have some presets to be applied to any channel. Select Wave. A panel opens with the wave parameters at the top and the motion effects view at the bottom. Let's place the panel to the right. Play the animation. The ball moves vertically following the wave pattern in the motion effects view. In the wave parameters, we can change the values and visually see the effect on the graph. Changing the period changes the frequency of the wave. Changing the amplitude modifies the height of the wave. Let's play the animation to see the effect. Change the decay rate. The graphic shows that the wave height or amplitude will decrease over time. Let's play to check. Yes, it works as expected. Close the panel and let's figure out how it works. At the moment, we are inside a motion effects network. Go to the object level, and next to our platonic object, a motion effects network has been created. In the tree view, we can see the nodes it contains. Remember, we applied the motion effects to the Y translation of the platonic object. Dive inside the network. The first node brings or imports the Y translation TY, so the Y translation is affected. To test, change TY for TX and play the animation. Now the movement is along the X-axis. Change TX for TC and play the animation. Now the movement is along the Z-axis. Type the original value TY and play the animation to check. In summary, this node sets what parameter or channel is going to be affected. The wave node sets a wave oscillation movement, and the last node is a math node. It just adds the wave movement to the imported parameter and also sends back this information to the Y translation parameter of the platonic object. Let's go back to the object level. In the Y translate field, we can see an orange bar and the indication that this parameter is overridden by the wave add node. Select the motion effects node and delete it. Now, select the platonic object. The orange bar has disappeared from the Y translation field, and this parameter is no longer driven by any motion effects network. Let's try another preset. Right-click on the parameter, then Motion Effects, and this time select Noise. A panel opens with the noise parameters at the top and the motion effects view at the bottom. Play the animation to see how the vertical movement for the ball corresponds to the motion effects graph. Here you can also change parameters and see the graphic results in the motion effects view. Let's change the period, the roughness, and the amplitude. Play again the animation. OK, close the panel. In the network editor, we have the first node to import the parameter to be affected, TY in this case. The second node provides a noise function, and the third node adds the noise to the affected parameter and exports the result back to the affected parameter. At the object level, we can see the Y translate parameter is overridden by the noise add node. OK, we have covered the basics of animation in Houdini. Thank you for watching this video. I'll see you soon in the next one.